Hey guys, I am making a tutorial for your linear function project. I've gone ahead and downloaded the instructions, and I have them open right here so you can see them. The first part, which there are 4 parts total, the first part is the data collection. So that's where we're going to go to usclimatedata.com, and we're going to find 10 years worth of data for the maximum high temperature of the year. And then after you find those 10 years worth of data, you're going to put it in a table. So we kind of already have what the table should look like here. You're going to put a year, and then we're going to start the first data point with a 0, and then you're going to put the maximum temperature for that year. So you're going to do that for 10 different years. So what we're going to go ahead and do is go to usclimatedata.com. I've already got it open. I'm going to go back to the home page so you can see how it looks when it started. I decided to look at Colorado Springs, so I clicked Colorado and then Colorado Springs. And then you need to check that there is 10 years worth of data. So here I have 2007 through 2018, so there's definitely enough. So now that I know enough, I'm going to go ahead and did I say that right? Now that I know there is enough, I'm going to go ahead and get started by clicking 2007. And then I know that the maximum temperature for the year is going to be in the summer. So I'm going to check June and see what the maximum temperature is. It's off to the right in the summary box, so 93.9. And then I'm going to click July. The high was 95. And then click August. The high was 95. So for 2007, the maximum temperature was 95 degrees. So if I look back at the table, I put the year was 2007. This is my first data point, so I put a 0 and then 95. And then I do the same thing for the next year. So I go ahead and I click 2008. I want to check the summer months. So I click June. I look and see that the high is 91. And then I look at July. The high is 97. Look at August. And I get 99. So the high for 2008 is 99 degrees Fahrenheit. So if you see here, I put 2008. This is my next point. So I started at 0, then put a 1. Then I have 99. So I did that over and over again until I got to 2018. Now, that is over 10 data points. But I figured, why not? The data's already there. So if we go back to the Word document, we can see that you're going to need to upload this. So make sure that after you create your table, so again, mine looks like this. After you create this, you're going to want to save it so that you can upload it in Blackboard. And I can show you what that looks like. But the second part here is graphing, and you can go ahead and make your graph in Excel if you want to, or you can draw it with, just pencil and paper. Your data points are not going to form a straight line. They're going to be kind of all over the place. If you look at the numbers I ended up with, it goes from 95 to 99 to 93 to 97. That's not all increasing. It's kind of increasing then decreasing and just, kind of sporadic. So I decided to go ahead and do mine paper and pencil because I had the time for it. And so you can see here, I went ahead and uploaded I just took a picture of it, and I have it on my computer. I have an x-axis. I should probably have a little arrow on the end here, but I labeled it, right? So I put these numbers stand for the years after 2007. I have my y-axis. My y-axis stands for the temperature in degrees Fahrenheit, and then I put a point for each spot. So, for point 0, if I look at my very first point, I got 95 for the degrees. So that's the first row in my table. 0, 95. My second point, with the 1 for the x value, I got 99. So I have a point there. 1 for the x, 99 for the y. 2 for the x, we've got 93 for the y, and so on and so forth. So I have these dots that are all over the place. So what we're going to want to do, if we see over here, is eventually we're going to want to go ahead and put a graph on there. So see here, we have choose 2 points from your data to form a best fit line. Draw a straight line through these 2 points. Try to choose the points that will ensure your line is as close as possible to as many points as possible. So then I said make sure you're labeling the axis. So x-axis, y-axis, make sure that your scale is clear and that you have a title. So I already talked about the x-axis and the y-axis a little bit, years after 2007, temperature in degrees. I have this weird little like squiggly thing here. What that means is there's a big break between 0 and the first temperatures I'm going to look at, and then I just scaled it by 1. So your graph is going to look different if you decide to go by 10s or 5s or something like that, or if you decide to do it in Excel. But you can change your scales there too. But I chose to use a point here, which was 0, 95, and then 7, 96. I think it was 96.1 actually. And I thought that that line was right in the middle of my data, and it kind of looks a little bit like my data. At least the bottom points did start kind of slightly going up. So I thought that it followed along with my data all right. Again, they are all over the place. You do have to be able to give a reason for why you chose the dots that you did. I thought that this made it so my line was as close to as many of the points as I could. I thought if I put it through this one, then it would be too steep and it would be very far away from the ones in the bottom. So these are the 2 points that I chose to use. Okay, that means that we're actually on to step 3. Step 3 is finding the function that your line gives. So I had a straight line, right? This guy, from all the points, I decided on those 2 points to put the straight line through. So I need to be able to come up with an equation. So I went ahead and did that here. I have the 2 points that I decided to use, 0, 95 and 7, 96.1. With 2 points, you can always find the slope of a line. So I went ahead and did that here. You have the change in y over the change in x. And then I used the point slope formula to find the equation of my line. So I plugged in 0, 95. I thought that would be easier for my y sub 1 and x sub 1. And I used the slope that I found and plugged it in, simplified my equation. I got y equals 0.157x plus 95. And then I wrote it in function notation. So f of x equals 0.15x plus 95. And that's going to be my best fit line function model data. That sounded really weird. The equation that I'm going to use. So then I would be ready to go ahead and move on to part 4. Part 4 is where you have all these questions using this function, so using this equation that we just found. So part 1 is asking about the slope of the function, and then it says in terms of year and maximum temperature, describe what the slope tells you about global warming. My dog is yawning right next to me. But so in my case, right, I'd be thinking, all right, is my slope positive? Is it negative? If it's positive, then that's predicting that the temperature is always going to get higher, right? So is that in line with what global warming is saying? And do your data points look like it? Because, if I look back at the points that I had on here, does that look like global warming's happening? You have to decide. Explain why you think it does indicate it or why it doesn't. But use your data, and so use your graph and use your equation for your rationale. Step 2, or question 2, explain whether or not you think your results indicate global warming. So we kind of talked about that. Number 3, using the function you created for this data, find f of 5. So I have f of x here. F of 5 is when you just plug 5 into your function, so you guys can do that. Number 3, using the function you created. Oh, sorry, I already said that one. Number 4, using your function, predict the maximum temperature in 2020. You have to be a little bit careful there because 2020 is not what you're going to plug in. Remember that my x values is the number of years after 2007. So I have to find how many years after 2007 2020 is. So 2020 minus 2007, get that number, plug that one in. Now, yours might be different if you started with a different year. Maybe you started with 2008. Maybe you started with 2006. If so, then yours is going to be a little bit different, and that's okay. And most likely your numbers will be different. In fact, they should be. If they're exactly the same, you will not get credit. It has to be something that you did, not me. Okay, number 5. Number 5, in business, decisions are made based on data. Therefore, it is highly important to be able to determine the best data for any given situation. If you are going to present to a group of lawmakers about the impact of global warming, you would want to show them convincing data that global warming exists and to what extent. List and describe 2 ways, that should have an S on it, that you could manipulate the data in order to make your results support the theory of global warming more convincingly. Is this ethical? So, this is what my data looks like right now. Is there a way that I could make it look even more like the temperatures are increasing? What are some things I could do to show that? So I want you guys to think about that. I also wanted to show you what it's going to look like when you actually go to Blackboard. So when you go to Blackboard and click on the test file, you'll end up with something that looks kind of like this. It'll look a little bit different for you. This is what the editor looks like. So I went ahead and I used the same exact instructions that are on the Word document, so it should look exactly the same. Notice the points are different because for the very first part I asked you to submit your table, and I felt like that took a good amount of work. So I went ahead and said that that was worth 10 points. And then the next part was graphing, and I felt like that was a good amount of work too. You got to plot all your points and then pick 2 points to put a straight line through. So I said that was worth 10 points as well. Make sure that you're labeling your x-axis, your y-axis, and that you're putting a title, and that your scale makes sense, right? Are you going by ones? Are you going by tens? And that sort of thing. Part 3, I put 5 points for that one. That's where you're finding the equation of your line. So you just have to pick 2 points, find the slope, use the point slope formula, and simplify. Write it in function notation. I felt like that one was a little less labor intensive, I suppose, than the other ones so far. And then the questions from part 4. Now 2 of them I thought were had a little bit more involved. So a few of them are 2 points, so where you're just plugging 5 in, or where you're predicting in 2020, that's just plugging something in as well. When you're just asking for the slope, I thought those ones were pretty easy, so those are 2 each. And then some of them are worth more. So explaining why you think it does or does not indicate global warming. And then also the business decisions one is a little bit more, just because I want you to explain why you came to the conclusion that you did. So expect that when you get into Blackboard. But other than that, I think you're probably ready to go. So please let me know if you have any questions, and I will see you later. Bye.